Hello? Okay. Good morning, everyone. Welcome to Cloud Data Warehousing with Azure Synapse Analytics session. My name is Igor Stanko, and I'm part of Synapse program management team, specifically responsible for our data warehousing capabilities. And I'm super happy to announce that we also have Finn from Unilever, who is going to talk a little bit about what Unilever does with their data warehousing environment and how they use Azure Synapse Analytics and their experience with it. Okay, so just before this session, I was at the booth and I was talking to a person and someone asked me, hey, you guys talk about analytics and Azure Synapse Analytics, what about data warehousing? And so this is the session to be. So we are super excited about what we are about to introduce. The session is gonna focus on how we are expanding our data warehousing capabilities and what is it that we are doing within core data warehousing within Azure Synapse Analytics. And then we're going to go through a session where we actually showcase some of these capabilities that we are about to announce. And then Finn is going to talk about their experience with Azure Synapse Analytics. All right, so before we go into details, one first question. So how many people use SQL DW today? OK, good. How many people evaluate SQL DW? Awesome. All right, so first we're going to go a little bit positioning. Earlier this week, we announced Azure Synapse Analytics. What is Azure Synapse Analytics? It's an evolution of our existing SQL Data Warehouse service. We are adding additional capabilities into the service. We are adding data integration. We are adding additional big data analytics as well. And with the whole intent to optimize how you implement your end-to-end analytical solution with the system. So hopefully, you guys have seen, oops, one slide is missing. OK, I'm missing a slide, apparently. The way Azure Synapse Analytics is designed, there is 4 core components within Azure Synapse Analytics. One is what we call kind of data warehousing and SQL analytics, or doing analytics with SQL itself, SQL engine, and it's going to come in 2 form factors. Yesterday, there was a session that Charles and Joseph did on the on-demand capabilities. So today, we're going to focus on our cluster-based capabilities and what is it that we are doing with provisioned resources. And then there is other capabilities that we spoke about, data integration, as well as big data analytics that includes Spark, as well as our Synapse Studio that is the development environment for doing all the analytics. OK, so let's dive. There is lots of content that we need to cover, so we're going to go fairly quickly through these announcements. So we had a few months ago, we announced results caching as a capability that was in public preview. We as a team are super dedicated towards ensuring that we deliver differentiated capabilities and differentiated price performance characteristics within the system. And so today, we are announcing GA capability of results caching. So what that does, we designed this capability specifically to ensure that we deliver those millisecond responses for your dashboarding type of scenarios. If you think about dashboarding, dashboarding comes with very, very predictable query patterns. When you first time run your dashboard, we're going to take those queries, and we're going to execute spending compute cycles to ensure we deliver those interactive query responses. Very next, dashboard refresh. Rather than recomputing results over and over, we're going to retrieve those results from results cache itself, leading to those millisecond response times, if you will. 2 main core benefits with results caching. One is that it's fully managed cache. You as a user, you don't need to do anything to maintain that cache caching system. As your users, as you ingest data into data warehouse and your base tables, we will automatically invalidate the results caches or entries within the results cache, as well as your users exercise and run various queries within the system, we will automatically populate those cache entries as well. So nothing that you need to do within the system, fully managed and automatic management of results caches. There is a statement how you enable results caching. You go to your database, alter database, turn on the results caching, and system just works out of the box for you. Another performance feature that is designed to ensure that we deliver those interactive query responses is materialized views. How many people implement materialized views today? OK, few. So where this really lights up is as you start thinking about a broader set of analytical queries that you need to support within the system, If you are hitting your base tables, whether that table has billions or 10 billions of records, there is certain performance characteristics that you're gonna get from the system because those are large objects. Typically, when you have your dashboarding scenarios, you start with the higher level queries such as, give me sales from my region and how much revenue did I make within that region. So to support those aggregated scenarios or aggregated queries, we do support deploying materialized views within the system. The way materialized views work is that you create a view on top of, materialized view on top of your base tables. You can define aggregations within that, like mean, max, average, all the aggregations pretty much are supported within the system, as well as you can support joins as well. So you can define materialized view that's based on join. If you have very complex join type of queries within your dashboarding or other interactive queries, we can effectively deploy those materialized views to match those joins algorithms and then leading to good performance results from the system. Few benefits again here as well. It's fully managed materialized views, meaning that as you ingest data into your base tables, we will automatically maintain materialized views. So nothing for you to do. Once you create materialized view, it will be fully managed. As well as you run your queries, your users don't need to be aware of these materialized views at all. System fully transparently functions and delivers the results where appropriate from materialized views. Users see base tables, they point to base tables, they query base tables, and then the system will automatically rewrite those user queries to leverage these materialized views, giving these interactive response times. Okay, so I'm sorry. Another question for anyone. So how many people run multiple workloads within their data warehouse environments? Okay, so when we say multiple workloads, typically people load data into data warehouse, run dashboarding type of scenarios, run ad hoc queries, right? So earlier this year, we did announce GA capability of ability to prioritize how these workloads run within the system. Today, we are announcing workload isolation support. We are expanding that workload management capabilities that we have. So we are announcing isolation support where you can decide how many resources, how much resources are reserved for those particular workloads that run concurrently on the system. As you run your ETL and dashboarding and ad hoc queries, all of those workloads are fighting for the resources that are deployed within the data warehouse, potentially leading to you missing an SLA for that particular workload. It's not uncommon. I run my ETL. As my users come onto the system, they run their own queries. What happens, they disrupt my ETL, and I missed SLA. With workload isolation support, you can actually design how many resources are reserved for that ETL process, ensuring that when that runs, other workloads do not disrupt your loading process, so you can satisfy that loading SLA. System can be configured in two ways, just to give you a lot more flexibility as far as how you leverage your resources. One is you can design your resources as dedicated resources or reserved resources, meaning that if I have 3 workloads that I onboard on my system, if one is not running, other 2 are running, these 2 will not be able to consume the resources that are reserved for that particular third workload that is not running. The other model that we also support is that you can design your resources as shared resources. What that means is that one workload is not running. Other 2 workloads can tap into resources that are reserved for that particular workload, giving you basically better utilization and leverage of all the resources that you deploy within the data warehouse. Each model comes with pros and cons. Kind of reservation comes with very, very predictable environment where the workload, when it comes in, the resources are waiting for that particular workload. You can immediately start executing that particular workload. On the other hand, other model comes with a state where you can completely leverage all the resources that you deploy with your data warehouse for other workloads, so leading to better utilization. Now, the second model, shared resource model, also has a downside because when one workload, let's say your user, you gave them access to data warehouse, because other workloads are not running in the system, they get access to all the resources that are deployed, right? Leading to potentially better performance results than when other workloads are running in the system as well. And so they may experience some unpredictable responses. They may reach out to you and say, what's going on? Having said that, you have flexibility to deploy both together. Not only that, you can actually mix the two models itself within the single system as well. Any changes to the workload management are fully online operations, so there is no need to shut down system and whatnot. As you adjust your policies, workload management policies, those take immediate effect, and you can just make adjustment as you go. Typical scenario is as I load my data sets, I may want to give, let's say, 80% of resources to my ETL. I can make policy adjustment, give 80% of resources. My ETL is done. I can automatically scale back and now give 80% of my resources to my users. So full flexibility and fully online operations, giving you that elastic behavior within the service. OK. So another thing that we are pretty much evolving our data warehousing capabilities, core data warehousing capabilities, is around the IoT scenarios. We constantly heard lots of feedback from customers that there is all these IoT scenarios where the devices send data into Azure for analysis. Today, the way we enable this scenario is all the data sets, all these streaming data can be uploaded into Azure Data Lake. And then you can use Polybase or our loading utility to load the data into Azure Data Warehouse. Today, we are announcing a native streaming capability where from within the data warehouse itself, you can go to our portal or data warehouse or Azure Synapse portal. You can point data warehouse to your event hub or IoT hub, configure the pipeline, and we'll start ingesting data directly into your data warehouse, leading to better and quicker insight into the data that is ingested immediately. Not only that we enable streaming ingestion, I think what's unique about us is that we are taking this to the next level. We are enabling ability to perform streaming analytics over streaming data as well. In other words, if I have multiple streams coming into the system, I can do joins across streams. I can do aggregation. I can do tumbling windows. I can do windowing aggregates. So very, very rich and robust functionality over the streaming data sets. We are super excited about this functionality. Now, the best thing is all of this comes within your T-SQL experience and environment. OK, so another innovation in the loading area is today, how many people use Polybase to load data into data warehouse? Pretty much everyone. That is the way to load data into your data warehouse environments today. So what we are introducing is a very, very simple way of loading data into data warehouse, specifically copy statement. Today, Polybase requires you to create pretty much 5 or 6 different statements before you can load data into the data warehouse. Things such as external data source, credentials, external tables, and so on. So all of that is going away. Our copy statement with the public preview as of today simplifies completely how you ingest data into data warehouse. So you can point this copy statement as shown on the screen. You can use this copy statement to point that to a flat file, and you can load data directly into data warehouse without any external table configuration whatsoever. There's some additional functionality that we enable within the copy statement itself. You can use the wildcard, so you can actually say, I want all files or subselect of files within that particular folder, multiple folders and whatnot. In addition to that, we also enabled almost like a small mapping capability where you can say, if I have a flat file with 100 columns, I'm interested only in 10. You can point basically to those 10 columns that you're interested in, and then you can load them into a target table within data warehouse itself. It's a lot more flexibility as far as how you load data into data warehouse. OK, so we are not stopping there. So we, as a platform, we are committed to enable multiple workloads that you can run within your data warehousing environments. So today, we support batch workloads within loading data into data warehouse, interactive queries. We just announced earlier streaming analytics support. We are also enabling native machine learning capabilities within your data warehousing environment. Specifically, we are enabling prediction support for data that lives within the data warehouse. Today, typically, people, as they build the predictive models, they extract data from data warehouse into various environments to do the prediction. The problem with that is the data warehouses come with large data sets. Extracting the data sets outside to another system is pretty painful process. So rather than extracting data outside, we are saying, why don't we bring those models into data warehouse so we can perform local prediction where the data lives, leading to better performance characteristics. The beauty of the system is that we are not enabling just simple machine learning algorithms such as logistic regressions and whatnot. We are enabling support for more complex algorithms such as SVMs or decision trees or deep neural networks for that matter. Whatever model you have, bring it into data warehouse, and we can actually do the scoring based on the local data that lives within data warehouse. Couple of things. You can use whatever framework you prefer to train the model, as long as that model can be converted into ONNX, which is interoperability framework for exchanging the models within various systems. Bring that model into data warehouse, and we can do local scoring for the data that lives within our environment. And you see native prediction model, native predict statement, and how it looks like in the lower graph. Okay, so yesterday, Charles and Joseph showed our capability to consume Parquet file formats in on-demand fashion with this SQL Analytics on-demand capability. We are, as a company, as a group, we are committing to make sure we announce Synapse as data warehouses and data lakes are merging together. We truly believe in that. So we are announcing also improved performance for Parquet file formats within the cluster form factor itself. So what this means is that today we have Polybase that allows you to kind of query data within the lake. We are enhancing that capability with what we call Parquet Direct capability. What we've done is pretty much we brought that Gen 2 capabilities that come with the price performance characteristics, leading price performance characteristics that we have. All these SSD caches, in-memory caches, as well as results like caching that we just spoke about and announced, all of that is coming on top of Parquet data sets within the data lake. Our goal is to support those exploratory scenarios where people try to figure out what data exists actually within the data lake in very, very interactive fashion. And you'll see I'm gonna demo some of this functionality. The goal is to, within seconds, get quick insight into the data that lives within the data lake. Okay, so here is the performance characteristics. This is basically a graph that compares where Polybase is today and what this new Parquet Direct functionality brings. What we've done is basically we loaded TPCH as a workload, 1 terabyte workload into data lake. We converted file format from files into Parquet. We ran Polybase as of today, and then with this new functionality, as you can see, we improved performance by over 13x where Polybase is today. So as we move forward, Polybase is going to be key investment for us. How do we merge these data warehouses and data lakes together in a blended environment, as well as we're going to continue innovating in this area and enable more performant access to other file formats as well. So yesterday, Azure Data Share did announce data sharing capability going into GA as a GA capacity. Azure, just a reminder that Azure Data Share does support Azure Synapse Analytics as ability to share the data that is stored within Azure Synapse Analytics as well. There is few things that we support within that environment. You can share kind of one-to-many type of scenarios. You can have Azure Synapse Analytics, specifically SQL data stored in SQL data store. You can share that with many consumers, as well as you have option to choose, is it a single table, multiple tables, is it view? So you as a data provider control what data will be exposed to other consumers of your data set. It does provide with some UI capabilities that allows you single pane of management to see how much data was exported, how often people consume these data sets, as well as are we satisfying the SLAs that are predefined. And it does come with the flexibility as far as who pays for data sharing. I think today it's consumer that is paying for the consumption. There is plan to actually introduce this, evolve this, and allow providers also to pay for data consumed. Okay, so we went through lots of functionality, new functionality, but there is a lot more that we are announcing today as well. We don't have time to go through every single one. I'll just highlight a few ones that are on this slide. There is additional performance improvements that we've done with our column store technology. Now you can actually, as you ingest data into column store, you can order the data set, leading to better data scans when you run queries, leading to better performance ultimately for your ad hoc queries. In addition to that, we are GAing also JSON support. So not only that we function with the structured data sets, you can actually upload JSON data as well and get that stored and managed by data warehouse. We believe in security. Every customer we talk to is concerned about security and how do you handle data within our environment. We have rich security functionality already, perhaps leading functionality in that area compared to other vendors in this market. Having said that, we are not stopping there. We are adding additional functionality, specifically dynamic data masking. So for those private data sets that you want to protect and don't want to share with anyone or with other people that are not supposed to see that, we are providing dynamic data masking capability, as well as we are enabling in the public preview fashion private link support. So you can protect those endpoints within your enterprise. We are also GAing our SSDT support for those CI/CD scenarios. So we are committed to provide premium experience for our developers who develop solutions on top of Azure Synapse Analytics. So today we are announcing also GA support for that CI/CD pipelines that you can fully automate how you go from dev, test to production environments. So with this, we are also adding few of these. 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 We are also adding few additional capabilities that are specifically tailored towards supporting those migration scenarios. So if you have existing Teradata, Netezas, as you may know, those environments do support multi-column distribution to deal with the data skews at rest. We are introducing support for both multi-column distributions within Azure Synapse Analytics, as well as we are making them updatable. As you increase how many columns need to be that part of your distribution strategy, if you will, obviously that reduces the number of columns you can update. So we want to mitigate that by allowing you to update distribution columns directly as well. Awesome. OK, demo time. OK, so what we have here is the setup for the demo. So we have a New York taxi data. So basically, taxis are trolling through the city and taking passengers to various destinations. So what we're going to do as taxis are trolling, basically they are emitting telemetry data. We opted in to store basically the engine heating characteristics. So as you drive, is there opportunity for engines to overheat? So we're going to stream that data directly into Azure through Event Hub and directly into Data Warehouse. We also have other data sets that live within the data lake itself. Things such as how many rides we made, what was the price that people pay, and whatnot. So we want to do some analysis over that data set, as well as we want to combine these together with other streaming data sets. We also will do some prediction to demonstrate native prediction capability. So what we've done is we loaded data into Azure ML. We specifically used the AutoML capabilities, and we used the data set to train the model. As you can see, AutoML went through various algorithms and picked and chose, let's see, which one is the voting ensemble algorithm that was chosen as the best prediction model to be used. We uploaded this model into Data Warehouse, and we're going to demonstrate prediction. We're going to basically predict what is the price of particular ride is going to be. OK. So let me go and I talk about streaming. Let me actually enable streaming, start streaming job, and I'll go through the full experience as we go through. What you'll notice, this is our existing portal capabilities. So let me just enable streaming, and we'll go through this whole experience as we go. Okay, let me start the streaming job. Okay, so let's go back to SSMS. So everything that we spoke about, it is available, all those capabilities are available in our GA service that we already have today, as well as it's fully available within our Synapse Studio environment that you guys have seen and that we announced. There is no difference. They have full parity capabilities-wise. Okay, so the first thing I'm going to do, I mentioned that I have some data set. Okay, my credentials expired. So let's rerun this. Okay, so I have data set in data lake, so we want to enable these exploratory scenarios. So first thing, what I'm going to do, I'm going to ensure that I clean the memory, so you guys know that it's not data that's coming from within the memory. So first thing is we're going to do, let's figure out how much data we have within this yellow cab data set. So it's 1.5 billion records that we have inside the data lake. So the next thing we want to say, okay, so who are all the vendors that provided us with the data set? So I'm going to run quick distinct over the data set, and you see I get very interactively response times from the data lake. So the next thing we want to do, let's identify what was the busiest month for us as within the taxi business. And you can see in 2013, actually in March, we delivered like 2.6 million rides, if you will. So the next thing within that month, we can go and figure out, okay, how many passengers did we give ride to, as well as who were the vendors who provided those rides. So you see we get the results. As you can see, very, very snappy response times compared to other solutions that are out there and what we have. Not only streaming ingestion, but also 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 streaming analytics capability. So let me actually open a job that I have predefined previously to show you streaming analytics being done within the data warehouse environment. So you can see what I have here is way more complicated job where we can do some aggregations, averages, as well as windowing functions, as well as tumbling windows. So very, very rich functionality to support all those analytical scenarios over streaming data that is coming into data warehouse. Okay, so let me finish this demo. Another thing that we were discussing is that materialized view support and how they help. So we don't have enough time, but I'm going to just quickly go over this. We have two tables. One table is basically deployed as a base table, and I have same copy of that table that has materialized view deployed. And I'm going to run, actually, I'm going to leverage just materialized views to see what kind of interactive responses we enable with this functionality. But trust me, the other query is way more complicated. It takes like almost 2 minutes to run. And once materialized view is deployed, it turns into sub-second responses. So this is my materialized view definition that I had. Let me just show you, this is a subset of the query that was used. Show you the plan for the original query that does not have materialized view deployed. As you can see, there is lots of movement that's happening within the system. We are broadcasting, we are shuffling data, joining data. So if I look into a table or plan that hits the table that has materialized view deployed, you'll see this is much, much simpler. So all those join operations as well as shuffling of the data is completely gone. And if I rerun this query now against the table that has materialized view, you see it gives me second response times. And the good thing about this is that, again, user points to a base table and is completely unaware that there is materialization that's happening behind the scene. System automatically optimizes execution of this. OK, and last part of the demo, we talked about the modeling and bringing the prediction inside Data Warehouse. So what we've done is, as I mentioned, we took that model that was built, we uploaded that model into Data Warehouse, and then we have trip data that is stored within the Data Warehouse, as we can see. So the next thing what we're going to do is we're going to use native predict capability to actually score data stored in Data Warehouse based on the model that was uploaded. So let me run this. It should take a few seconds. OK, there we go. So we see that now we have trip data, and also we are predicting what the cost is going to be for that particular trip by that particular vendor. OK, with that in mind, I would welcome Finn from Unilever.
Hi, is my microphone on now? Yeah, OK, great. Actually, can you use that? So thank you, everyone. Thank you, Igor. So I've been invited just to talk a little bit about Unilever's journey to the cloud and how our journey towards data-driven insights has really sort of been brought to life through Azure, and how we're now working with the newer releases of products, and particularly with Synapse Analytics, to really take our business to the next level of our data-driven insight journey. So I'm very proud to work for Unilever. I'm sure many of you will have heard of it. It's a massive global CPG company, and our turnover last year was about 51 billion euros. And there are many brands that you will be familiar with. Sorry. I can't do it. There are many brands that you'll be familiar with, like Lipton's and Hellmann's and Dove and others, which we are very proud to have in our stable of products. And 2.5 billion people every day use one of Unilever's products in their home or around the house. Okay. So our journey to the cloud from a data and analytics perspective really sort of started about 2 years ago, or a bit more than 2 years ago. And we worked very closely in partnership with Microsoft around the creation of the modern data warehouse. And our logical representation of this is the slide you see now, which actually is almost exactly the same slide as Jason Zander showed in his keynote speech the other day. And what we have is we ingest our raw data into Azure Data Lake Store, and we call that the Universal Data Lake. We literally do pull in all the data that we require for our data and analytics into that in its native form. And what that means is we never need to go back to source systems to get data if we want to restate any of our calculations or anything like this. And this is a massive unlock for us. It may sound really simple, and I'm sure all of you have experienced the fact that we've got data here, there, and everywhere. It's very difficult to get access to it. It's in silos. It doesn't join up very well. It's not cleansed. And actually having a very sort of structured approach to managing our data for all of our reporting and analytical needs on a global basis really does help to unlock some of those silo or data quality challenges that we've experienced to date. So we pull all the data into the Universal Data Lake. And then what we're doing is we're building what we call business data lakes on top of that. And they're still in Azure Data Lake Store, but what they are in effect is we just add some cleansing, maybe do some calculations, we join the data together and make it more available in that sort of business approachable format, whereas the raw data coming from SAP is not very approachable to your user community. And the processing for that, we typically use Databricks for that, using its Spark engine. And then on top of that, we build our products. So there are really our reporting and analytical solutions that our business want to use in order to answer business questions. And we use a combination of Azure SQL Data Warehouse, Azure Analysis Services, and Power BI for that. And this whole journey it's been very complex and very challenging, but what we've managed to do in the last 2 years is really significantly increase the speed of our ability to deliver solutions to the business. Massively ramped up the use of tools like Power BI. So a year ago, we had maybe 1,000 users using Power BI. Last month, we had in excess of 17,000 users. And that puts us in the top handful of customers from a Microsoft perspective for Power BI. And it really does put access to the data at the fingertips of our user community and really helps to democratize data analytics to our users. So I've just got 2 more slides just very quickly, and I'm conscious that what I'm going to say in these slides really does repeat a bit what Igor has just said in his session, but I think there are a couple of things that are really worth mentioning. So we use SQL Data Warehouse, or Azure Synapse Analytics, for over 50 of our projects today. And we use it in a sort of traditional data warehousing way, sort of facts and dimensions, and we really make use of the scale up and scale down capability that cloud really does offer. And I'm sure all of you are aware that on-premise you have to buy servers, install them, et cetera, and with something like SQL Data Warehouse, you literally go, well, we don't put our credit card in, but you can just put your credit card in, and you can get an instance, and you can spin it up and spin it down whenever you want. So you really can cater for the peaks and troughs in demand, which you really struggle on-premise. And some of the new features that have come out are really valuable, and if you're not using them, I really urge you to look at them. So reserved instance pricing is, I've always thought of it as being the world of IaaS, and really this has been brought into the world of PaaS now, and the opportunity to save sort of 30%, 50% or more of your SQL data warehousing cost is really available to you now. SQL data warehouse is not a cheap product, but through the scale up and scale down, through reserved instance pricing, you really can get it to be a much better competitive price point. Igor talked about workload management and workload isolation. These are really important, and it was a real sort of lack in the product up to this point, but it really is a big step forward. And I because of my relationship with the product team, I'm aware of some of the roadmap, which I'm probably not allowed to mention, but there's some really exciting things coming down the line in this as well in the near future. So keep on at your account team to understand more about what's coming, because there's some really exciting developments. And he talked about the result set cache and materialized views. Materialized views, again, so important. The ability to really run queries on some pre-processed data, but also being able to drill down into the more granular data if you want is so important to give really sparkling performance to our user community. And again, he talked about the fast queries over Parquet files. So don't bother going back, but really I think the key thing for me is it's really being able to sort of pull down the price point whilst increase the performance capabilities of the system. So into our sort of usage of the preview features of Azure Synapse Analytics. You'll have seen some of the presentations this week, and I think the key message for me is it really does give you that sort of single pane of glass, that single window onto your end-to-end journey of ingesting data, processing that data into your data warehouse, and being able to run big data queries or traditional SQL queries through that same lens is a huge unlock. Not having to switch from one tool to another, being able to use a no-code environment to be able to quickly deliver insights from data. So I've got an idea of how I might be able to generate some growth for the business. I can quickly get some data, process that, and do all of that in a single window without the need to go to IT to ask for an ADF developer and a SQL data warehouse data modeler or whatever. It really does unlock that. And I think the ability to really have that sort of centralized monitoring and alerting across the estate, again, in terms of if something ever goes wrong with any of your pipelines, it's all in that one place for you to see and be able to sort of drill into what's causing the problem and what actions I need to take to resolve that. And I think what you'll see is, although it's still a relatively nascent product, I think we will see it really rapidly develop over the next 6 to 9 months. And I urge you all to get access to it if you can in preview, play around with it and see the value that it can unlock for your business. And I'll hand back to Igor for any questions.
So, just a comment, many features that we announced today are in public or general availability capacity. You can actually consume, we are deploying this new functionality as we speak. There is few that we announced in a private preview fashion. So if you are interested in whitelisting us to working with us and us whitelisting into those previews, please reach out to us to this email and we'll work with you to get you onboarded. Okay, with this, any questions? I think we have maybe a minute or two for last minute question. Yes. Yes.
Basically, what runs behind the scenes to achieve workload isolation, specifically on the SQL layer? Because in my experience, storage I/O is a big point of contention when you run heavy workload.
Yeah. So the question is this workload isolation? Does it apply to compute only, or does it apply to storage as well? So as what we announced as of today, it applies to compute, leveraging memory as well as CPU. Our next step is to allow you to govern the IOP as well as the storage layer. Okay, thank you all for visiting us today. Please visit us at the booth. We are more than happy to take any other questions.
You mentioned the caching, right?
Yes.